All right. So let's just say I'm a contestant. Um, who thinks I should have a really small interval? All right. Who thinks I want a really big interval? All right, that's good, right? Because, well, if we have a big interval, well, then there's a bigger chance that my number is going to be in that interval, right? So I think a really large interval would be pretty good for me as a contestant, right? Another way to say this mathematically is if I have a large interval, then I'm going to be more confident that I'm going to win, right? Okay, just keep that in mind. All right, now let's say that I'm a show producer, okay? If I'm a producer of the show, um, well, what size interval do you think I want this time? Yeah, you want a small interval, right? Because you don't want them to win, okay? So small interval here would be best, okay? Now, I actually thought of two reasons why a small interval would be good here, okay? First of all, as a producer, I'm giving out money, right? And I don't want to lose money, and I don't want many people winning, because if a lot of people win, then, well, I'm going to start dishing out money left and right, okay? The second reason is kind of different, okay? Do you think you would want to watch the show if everyone won every single time? No, right? It wouldn't be very meaningful if every single person won the game. When I want to watch the show, I want to see someone like I feel kind of mean saying this, but I want to see them lose, right? I want to at least like have them have a good chance of losing. And if they win, it's like really exciting, right? So I definitely don't want a big interval as a producer because I want more people to watch my show, right? I want it to be more meaningful for something to win. Okay. All right, C and D are kind of redundant here. What would happen to the rate of prize winning if the red interval is narrow? Who thinks that the rate of prize winning will go up? Who thinks it'll go down? Cool. All right. So if the red interval is really tiny, that means less people are going to win, right? Which means the rate of prize winning will go down, which means if I have a really big interval, then the rate of prize winning is going to go up, right? Okay. So all of this is kind of leading up to my last question. Okay. Well, since really large intervals are, well, more likely to have the person win, right? Shouldn't every single interval be large on the show? Marky? Yeah, the producer's going to have, well, they're just going to be giving out money left and right, right? And they're going to lose out on, well, people watching the show, right? If every single person won every single time, then first of all, we're going to run out of money. And it's not going to be very meaningful for someone to win, right? If everyone wins the car or the trip to Rome, then it's going to be completely meaningless. No one cares, right? So let me just write out something here. When we do these questions in this section, there's a balance between confidence. Okay, confidence is like, okay, I'm pretty confident I'm gonna win, right? And meaningfulness. Okay. If I'm really confident that I'm gonna win, it kind of takes away from the meaningfulness, right? If you're a pretty confident person's gonna win, you don't really care if they win or not because, well, it doesn't mean anything if they win. If the confidence is low, then I'm not going to be very confident that I'm going to win the show, but it becomes super meaningful if I do, right? And there's a huge balance between these two in this section. We're going to construct these intervals. We're going to try to make the interval really big so that our number gets in there so that we win the game, but we can't make it too big or else we lose that meaning, right? We want it to actually mean something, okay? Another way I can think of this game is, let's say I was trying to guess the average age of a student at SU. Okay. Now I think it's probably what, like 19 or 20 or something like that. That's what I'm thinking. But would we be pretty confident that the average age of an SU student is between 0 and 100? Pretty confident that we have the number in there, right? Doesn't mean anything if I say that. No, right? I mean, everyone is pretty much between 0 and 100, right? Not many people above 100. I mean, maybe we have a bunch of old people at a university, but that usually doesn't happen, right? Now, I'd be less confident if I said that the average age of an SU student is between 19 and 20, right? But now I'm less confident that my number's between those two. I mean, it could be 21, could be 18. So now I'm not sure if I'm actually getting that number in, okay? So we have to play this game between balancing how big the interval is. We want it to be big enough, but we want it to actually mean something and not just be meaningless, okay? All right, so why don't we start bringing math into this, okay? We're gonna talk about how to construct our interval. And before we do that, well, I'm gonna be throwing a bunch of different symbols at you, okay? Starting this section, you're gonna see all these symbols just kind of jumbled around in these sections, okay? Now, before we do this, I forgot to put the sample size, right? Sample size. Anyone remember what symbol that is? N, yeah, perfect. N, or the number of things, right? So that's why it's N, okay? Going on to population symbols, who remembers the symbol for population mean? Mu, right? So it's the Greek letter for M, which is mu. What about standard deviation for the population? Sigma, right? Or it looks like an O with a line on top, but it really is lowercase s in Greek, lowercase sigma, okay? The sample mean, who remembers that one? X bar, perfect. And I feel like this one's the hardest one to remember for some reason, but what's the sample standard deviation? S, right? It's the simplest, but for some reason I always forget it. I don't know why. All right. All right, let's do example number 1. Okay, this is an example of a question that you might be asked in this section, okay? Here we have a simple random sample of 100 fourth graders. Okay, first of all, there's a lot of numbers being thrown at me, lots of words. I'm just gonna tabulate everything below the question just so I have everything written down. Since we have 100 things, I guess that's what N is. Okay, and this group is selected to take part in some sort of like experimental approach to teaching reading. Okay, after the approach, we're going to give them a standardized test, and from that test, the sample mean X bar was equal to 67.3. So I'm going to write that down too. Okay, now from the past, we actually do know that the scores have a population standard deviation of sigma equals 15. Okay, and the big overarching question in this question is, what's the population mean? Okay, what is mu? It's the big question. Now, we're only given 3 things. Okay, we're only given 167.3 and 15. I'll tell you right now that from these 3 pieces of information, I can't actually calculate what mu is. Okay, we cannot give a number for what mu actually is here. Okay, what we can do is we can construct an interval that we're pretty confident that mu is in. Okay, we can construct an interval. We actually won't be sure if mu is in it or not, but we can be pretty confident that mu is in there. Okay, now I guess how do you make that interval, right? So in order to come up with an interval, I guess we need to have like a starting point, like where it should be, right? We have 3 numbers. We have 100. Oh, there we go. We have 100, we have 67.3, and we have 15. Out of these 3 numbers, which one do you think is closest to mu? Who thinks it's 100? Okay, who thinks 67.3 is closest to the mean? All right, who thinks 15 is closest? All right, now we did get an outlier for 15, but I think we got most hands up for 67.3, okay? The reason behind this is we're trying to figure out what the mean is, right? I guess the mean would be closest to the mean, right? Now, usually the sample mean is not equal to the population mean, right? There's some sort of deviation there, but usually samples are representative, there we go, of the population. So, I mean, even though it's not exact, I would say that the sample mean is pretty close to the population mean. It's not going to be exact, but I would expect it to be somewhere around that range, right? So I'm actually going to call this my estimate, okay? Not just an estimate, though, a point estimate. Okay, and well, it's an estimate because it's closest to what we want, right? And it's the point estimate just because it's one number, right? It's a number, not like a bunch of numbers or a list of things. It's just one point that's closest to what I want. Okay. So we have like a good area as to where our interval is going to be, right? It's going to be somewhere around 67.3, okay? And the way we're going to create our interval is we're going to use this thing called a margin of error, okay? Has anyone heard the term margin of error before? Yeah, I think it's something that you kind of hear in real life. If you haven't heard what it is, I'll give you an example of where I would use a margin of error. Okay. So I think we're all familiar that we take all our exams online, right, for this class. I don't really like doing that, but our final is online, so I guess it makes sense to have all our tests online. Um, Whenever I write a question for a test, okay, I have to tell the computer what the correct answer is, right? So let's just say the correct answer is 6.7, okay? Now, I'll type that into the computer, okay? But sometimes, like when you do a calculation on your calculator or whatever, you might round it wrong and get 6.8 or 6.2 or something like that, right? Now, the computer doesn't know that, right? So it will see if you type in 6.8, it will just mark you wrong because it says the answer is 6.7. That's not the answer. So the way I get around that is I give the computer this thing called a margin of error. And I'll say maybe my margin of error is 0.2 or something like that. Okay. And what the computer will do is now we'll know that, okay, I know the right answer is 6.7, but anything around 0.2 or within 0.2 of 6.7 is also going to be marked correct. So even if you round your answer wrong, it has this margin of error where, okay, it's still correct, even though it's not like the correct answer. Okay. And that's basically how it is here. Okay. Let's just say that my margin of error is 10. Okay. So let me just kind of highlight the margin of error here is going to be 10. If you're wondering where I got 10 from, I literally just made up a number. I thought 10 was kind of nice to work with. I didn't do any calculations to get 10, just made it up. Okay. Let's just say I wanted to construct my interval. Okay. Well, I know that my interval has to be around 67.30 because I said that was the estimate, right? That's around where my answer has to be. Okay. I like to think of my interval as like a number line. Okay. Where my estimate is right in the middle and my margin of error will tell me how far to go above or below my number. Okay. So to get the higher number, I'm going to take 67.30 and I'm going to add my margin of error of 10. Okay. So that becomes 77.30. Okay. I'm also going to subtract my number 10 from 67.30. So 67.30 minus 10, that gives me 57.30. Can't believe I had to look at my notes for that. All right. So now we have a lower bound for my interval, 57.30, and an upper bound for my interval, 77.30. And what that's saying is, okay, well, my interval is between 57.3 and 77.3. Okay, so that's how we go about constructing our interval. Any questions on what I did here? Okay, I literally just added and subtracted the margin of error from the estimate. All right, I'm going to adjust the question real quick. Okay, now let's say that the margin of error is 2. Just made that up out of thin air there. Okay, I'm going to give you like 1 minute. I want you to construct your interval. Find the lower and upper number if the margin of error is now 2, not 10 anymore. Okay. All right. Let's go over this one. When I think of an interval, I just think of it as a number line. So I'll draw my number line. Okay. In the middle, I'll put my point estimate, which is the closest thing to what we want, 67.3. Okay. Did we add 2 to get the higher number? All right, good. So you're going to take 67.30. You're going to add 2 to it to get 69.30. You're also going to take 67.30. And did we all subtract 2? Cool. And we got 65.30 to get the lower number. These two numbers are kind of the endpoints of my interval. Okay. Now, just thinking about our interval here, when we had a margin of error of 10, my interval was a lot larger than the margin of error of 2, right? So the smaller the margin of error is, the tighter your interval is going to be, right? Because we went from 65.3 to 69.3 from like a much wider interval, okay? So that is what we can expect there. Oh yeah, the way that we write our interval, we actually can write our answer in several different ways, okay? One thing we can do is we can write it just showing how we got the answer. So since we took 67.30 and we added and subtracted 2, I can put a plus or minus between the 67.3 and the 2. So it's just to say that, okay, to get my answer, you take your point estimate, you add 2 and you subtract 2 and you get those two numbers. So that's one way you can write your answer. Another way you can write your answer is using interval notation, which is just like an ordered pair almost that shows the lower and upper number in your interval. Usually the lower number goes first, so 65.30 would go first, and 69.30 would go second. Okay, we would separate them with a comma. So that is interval notation, okay? And the last way that you can write your answer is just using like less than signs. Since we're interested in finding mu would go in the middle, okay? And we would just put less than signs using our lower number first and our upper number second, to just say that, okay, what we want is between those two numbers. Okay. Any questions on like writing your answer, anything like that? Yeah.
So, which one would be more accurate? 10 points or 2?
Oh, so that's a good question, right? So how do we even get these two numbers, right? I actually made those two numbers up just on the top of my head. On the next page, we're actually going to come up with how we calculate the margin of error, which kind of depends on how confident we want to be, okay? So that's a good question. Let's go to the next page and we'll actually figure out how to get the margin of error, okay? All right, so before we start talking about how to create this margin of error, when we talked about the range game, right? We said that how big the margin of error depended on, well, how confident we wanted to be, right? So how meaningful we are, how large the interval depends on if we want to be really confident that our number gets in there, or if we're not going to be that confident that we win the game, okay? Now, I'm going to throw this term around a lot in this class, a percentage of confidence, okay? In this question, I'm going to just say that I want to be 95% confident that I'm going to win the game. That's pretty good, right? If I'm 95% confident, I'm pretty confident I'm going to win, right? Now, we'll talk about what this actually means later on, okay? But for now, I'm just going to throw out that I want to be 95% confident. Okay, let's see how big the margin of error is going to be this time, okay? Before we talk about how we get the margin of error, we have to find two values. The first one is pretty easy, okay? It's called the standard error, okay? Now, I'm not going to get too much into detail in this class because, well, once you get kind of higher in statistics, you kind of realize how this is created. But I will tell you that the central limit theorem plays a very big part in getting these values, in getting the margin of error, okay? And because the central limit theorem plays a big part, I think we all remember this formula, sigma over the square root of n. We went over that on Monday, I think, and it is on your quiz, okay? The central limit theorem's equation, sigma over square root of n, has to play a part in this whole ordeal, okay? We actually have a very specific term for it. We call it the standard error, okay? And this is a formula you do have to memorize, okay? But you don't really have to memorize it because you already memorized it for the central limit theorem, right? So it's literally the same formula. This is called the standard error, okay? So don't really worry too much about like what this is, and all that stuff. We'll talk about it later. But let's just find the standard error in our example, okay? So let's find the standard error, or SE, okay? I know it's equal to sigma over the square root of n. And if you take a look back at the question, it's a good thing that I just tabulated everything over here, because now all I have to do is plug in our values, right? So I have 15 up top, and I have n square rooted on the bottom, okay? Personally, I like to do the square root first, write it down, and then divide. So I'll go ahead and do that. The square root of 100 is 10, right? And then 15 over 10 is 1.5. So this here is my standard error. Okay. So we're kind of getting there, okay? After we find our standard error, the next thing I want to find is something called a critical value, okay? Now, I'm going to tell you how to find the critical value, but I will tell you that there is an easier way to find it, okay? We're basically going to have a chart that tells us what it is, okay? But because this is a stats class, I kind of want to give you an idea of where the critical value comes about, okay? Now, I did say I wanted to be 95% confident, okay? So what we're going to do is we're going to take a look at the normal distribution, which came about using the central limit theorem, okay? I'm going to take my 95% confidence, okay? And I'm going to use that to section off the middle 95% of the normal distribution. So not just like left or right, I'm taking 95% and just sticking that right in the middle of my graph, okay? So I'm kind of shading in this area, okay? What I want to do is I want to find the z-score that represents Well, each of these points that I use to section off that middle 95%, okay? And I actually did this on Minitab like right before class. This value is negative 1.96, and this z-score is positive 1.96, okay? And they're actually always going to be like the negative and positive version of each other. The positive version, 1.96, is the critical value, okay? Now, in this class, I'm actually not going to require you to like use Minitab to find these values. We're going to have a special chart that will tell us what those values are. But for now, just kind of keep this in mind, but I'm not going to require you to do this, okay? So just so we have it in our notes, the z-scores are negative 1.96 and positive 1.96, okay? Which means 1.96, the positive version, is the critical value, okay? Now what we can do is we can come up with our margin of error, okay? The margin of error has a very simple formula, okay? This is a formula you have to memorize, okay? To get the margin of error, you multiply the two numbers that we just got. So our critical value and our standard error, just multiply them together, and that's your margin of error, okay? So if I wanted to find the margin of error here, I'm going to take my critical value, 1.96, my standard error, 1.5, multiply them together to get 2.94, which is my margin of error here. Okay. Any questions on how I just got this? Cool. All right. Well, let's go ahead and construct our 95% confidence interval. Same thing as we did before. We're going to set up our number line. The number in the middle is our point estimate. It's the number closest to what we want, which is the population mean. So taking a look, our point estimate was 67.3. So that's going to go right in the middle. Okay. And to get my upper and lower numbers, I'm going to add and subtract the margin of error. So 67.30 plus 2.94 is 70.21. I'm going to take 67.30 minus 2.94, and that gives me 64.36. Okay. And those are the two edges of my interval. So a couple ways we can write our answer. We can write 67. Oh, didn't write that. 67. Oh my goodness, 0.30 plus or minus my margin of error, because that's how I found those two numbers. I just added and subtracted. You can write this in interval notation, 64.36 comma 70.21. Okay. Or we can use the less than signs, right? So we can do 64.36 is less than what we want, the mu, which is less than 70.21. Okay, so 3 different ways you can write your answer. Okay, finally, for these questions, I'm always going to ask you to interpret your answer in words, okay? And I feel like a lot of us aren't used to this, but in statistics is kind of like an English class, okay? Normal math classes, you just write your answer and that's what you're graded on. Statistics, actually, the way that you say your answer matters. And if you say the wrong thing, or you say what you want in the wrong way, you're going to be marked wrong, which kind of sucks, but you'll get used to it, okay? This is how I would interpret our answer, okay? And I'll explain what this means later, but this is how I'll say it. We are 95% confident, okay, that what we want, the population mean, which is mu, okay, is between the two numbers that we just found, 64.36 and 70.21, okay? Now, I will actually give you a template as to how you write your answers in this class, but I'll warn you right now from the beginning that if you do not write your answer this way, there's a very high chance that you're going to get the question wrong. There are other ways that you can word this, which, I mean, I'll mark correct if it makes sense, but there are other ways that you could say this that will be marked wrong, okay? All right, so let's just recap what we did here, okay? First of all, we found the standard error using the formula, right? We found the critical value, and I told you, don't worry about how I did it with the z-score. There'll be a much easier way to find the critical value later, okay? The margin of error is just multiplying your two numbers together. Once we find the margin of error, which was 2.94, you take your point estimate, you add and subtract the margin of error to get your values, and then you say your answer in a very specific way. Okay. I have a very systematic way to do these questions later on in this class. So I guess on Friday, what we'll do is we'll like talk about how to do this in a very step-by-step manner. And it'll be a little bit easier for us. But for now, I do think we have a quiz review to go over. So I think that's what we're gonna do next.